Hey there, so this is the last part of this section, which is scientific notation. And so with scientific notation, it comes up at a lot of in science, and we'll also use it quite a bit in math. But for example, say I give you 4 times 10 to the fifth. So what does that mean? Now 10 to the fifth, notice that's 10 multiplied by itself 5 times. So this is really like saying 4 times 100,000, right? 5 zeros. And so what that means is that then sometimes you'll see this written as 4 with the decimal 4.0 times 10 to the fifth for scientific notation. So what this means is that you're going to move the decimal place 5 times to the right. Since this is positive, you're going to move to the right. If it was negative, you're going to move to the left. And so 1, 2, 3, 4, 5, that's where the decimal place will go. So you need 1, 2, 3, 4, 5 zeros. And so in this case, you get 400,000, which is really 4 times 100,000. So that's um, kind of like a slightly less complicated way to think about scientific notation. Now, like I said, if you had a negative number, so say I had 1.72 times 10 to the minus 8. Now, the 10 to the minus 8, as we've talked about with properties of exponents, right? This means you're really multiplying by 1 over 10 to the eighth. So you're really dividing by 10 to the eighth. So that's what makes it the decimal point go to the left, because you're really dividing, which makes the number a lot smaller. So in this case, we're going to think of 1.72. We're going to move the decimal place to the left 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. So that's where your decimal place is going to go. We can add a zero placeholder. So 1, 2, 3, 4, 5, 6. We end up adding 7 zeros, but that's because the eighth place is taken up by the 1 there. So our final answer will be 1, 2, 3, 4, 5, 6, 7 zeros, and then 172. So that will be what 1.72 times 10 to the eighth is. So that's the final answer for that. And the properties of exponents still apply for scientific notation. So for example, if I ask you to simplify, or sometimes you might be asked to compute 2.1 times 10 to the minus 3, say, times 0.291 times 10 to the 12. So in this case, you treat the number part together. So this is going to be 2.1 times 0.291, and we're going to multiply this by 10 to the, and then notice that since we're multiplying the same basis, 10 to the minus 3 and 10 to the 12, we add the exponent, so it'll be minus 3 plus 12. So you end up getting 2.1 times 0.291 times 10 to the negative 3 plus 12 is 9. And now on your calculator, you're going to do really quickly 2.1 times 0.291, and you end up with 0.6111 times 10 to the ninth. And this will be your final answer. I hope that helps with scientific notation. Sometimes you may end with something, let's say another example where you end up having to divide. So if I had 2.1 times 10 to the minus 3, like I did above, times, let's try the same thing, times 10 to the 12. But say you're dividing by 2.3 times 10 to the fourth. Now you're going to treat the numbers the same. So it's going to be, you're going to have 2.1 times 0.291 divided by 2.3, and then you're going to have times 10 to the, so we're going to have the same thing, negative 3 plus 12, because we add the exponents, but now you're dividing by 10 to the fourth, so you're going to have minus 4. And looks like here I'm just running out of room, but you're going to have your exponent will be minus 3 plus 12 minus 4. Okay, so you can try that and see what you get, and you can email me to get what the final answer is and see if you did it right.